If you're looking to increase the magnification of your telescope, you've probably heard about the Barlow Lens. In this video, we'll learn everything about a Barlow lens, and we will also see how to choose the right Barlow lens according to your needs. But before we go further, you need to know some basic concepts of eyepieces, so make sure first you watch this video. So what is the Barlow lens? A Barlow lens is the optical instrument used in between your telescope and the eyepiece. It is one of the most flexible instruments for a telescope. It was invented by Peter Barlow, and the most important function of a Barlow lens is to increase the magnification, usually 2 to 3 times any eyepiece. Barlow lenses achieve this magnification by increasing the focal length of a telescope. In photography, the teleconverter does the same job as the Barlow lens. Let's see, how does a Barlow lens work? The magnification formula for a telescope is the focal length of a telescope divided by the focal length of the eyepiece. From this formula, you can get a higher magnification in 2 ways. The first method is by increasing the focal length of a telescope, and the second method is by decreasing the focal length of an eyepiece. So when you insert a Barlow lens in between a telescope and an eyepiece, it increases the focal length of the telescope, ultimately giving you a higher magnification. In other words, you can also say that it decreases the focal length of an eyepiece to achieve the desired magnification. Let's see an example. Here's a telescope without a Barlow lens. When light passes through this telescope, you can see the focal point is at the focal plane of an eyepiece. Now when you add a Barlow lens, the focal point is at the end of the Barlow lens, or you can say that at the eyepiece again. But this time the focal length is stretched by the Barlow lens. This gives you a higher magnification for the eyepiece you use. Let's see some of the advantages of that Barlow lens. 1, it increases the magnification of your telescope. And 2, it saves money. Instead of buying different eyepieces for magnification, you can achieve similar magnification with the eyepieces you already have with the use of a Barlow lens. 3, when you use higher magnification eyepieces, they will usually have lower eye relief. But with the Barlow lens, you can convert the low magnification eyepiece into a high magnification eyepiece and keep the eye relief the same as before. We explained this with an example at the end of the video. 4, if you travel a lot to different stargazing locations, then carrying more stuff is not ideal. By using a Barlow lens, each of your eyepieces now has 2 magnifications, and ultimately it saves space in your telescope kit. As it has some great advantages, it also has some disadvantages. 1, it will give a slightly dimmer image. But if you buy a really good quality Barlow lens, then this effect will be very minimal and you won't even notice it. And 2, as these are lenses, so you may see some optical aberrations, but this can be avoided if you use a high-quality Barlow lens. So which Barlow lens should you choose? The Barlow lens comes for different desired magnifications. It varies from 1.5 times to 5 times magnification. Usually the most suitable and the most efficient are the 2 times magnification of a Barlow lens. But if you already have a telescope, then first check which eyepieces you have. If you're thinking of buying a telescope, then see in the specifications which eyepieces come with that telescope. Let's say you're buying a Nexstar 102 SLT telescope. This telescope has a focal length of 660 millimeters. The highest useful magnification of this telescope is 241 times, and the lowest useful magnification is 15 times. With this telescope, you get 2 eyepieces, a 25mm and a 9mm. The magnification of this telescope with these eyepieces is 26 times and 73 times. Now, if you buy a 2 times Barlow lens, then the 2 additional magnifications you get are 52 times and 144 times. If you use the 4 times Barlow lens with this telescope, then you get 2 more magnifications, 104 times and 292 times. The highest useful magnification of our telescope is 241 times, so having a magnification greater than that will be of no use. So it's better to stay with the 2 times Barlow lens. Another example is, let's say you have a 10mm, 20mm, and 40mm eyepiece. Now, if you use a 2x Barlow lens, then this Barlow will make your eyepieces a 5mm, 10mm, and 20mm. But you already have a 10mm, a 20mm eyepiece, which gives you the same magnification. So the majority of the output of this Barlow lens is not useful in this case. So in this case, you can go for any other Barlow other than the 2x. The exception to this case is if you have a really good high-quality eyepiece that has a high eye relief, then a Barlow lens will still give the same eye relief even after reducing the focal length of that eyepiece. For example, usually a 5mm high magnification eyepiece will have a lower eye relief compared to a 10mm eyepiece. But when you use a 2x Barlow with a 10mm eyepiece, it will give you the same result as a 5mm eyepiece, with the eye relief of a 10mm eyepiece. If you use the 4x Barlow with a 20mm eyepiece, you will get a similar result with much greater eye relief. So this is how these Barlow lenses usually work, by giving more efficient magnification and also saving money and space in your telescope kit. We hope you understood everything from this video about a Barlow lens. And if you did, then give it a like and subscribe to the channel for more such content.